Yes, so I would like to thank the organizer for inviting me. I'm really excited to be presenting at DialDoc. And before I get started, I would like to, well, of course, acknowledge people who have been working with me on the subject of this talk. I mean, most of the work I will be presenting today is based on the work of two great interns, Felix Foltings and, well, Ellen Wu. And also, I would like to acknowledge many other people from Microsoft Research and other people who visit Microsoft to help with this work. So, well, I needed to think a bit about how to best present this work to this workshop, because I think, I mean, well, of course, much of the audience is interested in dialogue, and I think that's something very important in terms of helping kind of grounding to help create better conversation, and that's and I've been also working on that space. Well, I would like to draw a distinction here between what this workshop is more generally about and this talk, and I think the two are very related. So in this talk, I'm going to presenting kind of what's the flip side of that, which is basically when generating content like a document, we want to have some kind of interactivity or maybe a kind of user envelope to be able to do that. And I think the two are very related. So, I mean, if you look at actually at the bottom, kind of the words are kind of the same, but shuffled in different direction. But I think the reason this kind of line of work, what I'm talking about today, is very relevant also to dialogue research, because at the end of the day, when you're creating, let's say, a document, interactivity, that becomes essentially a new form of task-oriented dialogue. And I kind of mention that a bit later on and say why this is important and what this might be as helpful. But before I get to the motivation part for dialogue researchers, let me kind of present this a bit more broadly and say where we're getting at, what we mean by interactive document generation or interactive content generation. So as you're very well aware, there's been kind of really impressive results lately with deep learning models that can do really kind of impressive things in terms of content generation. I mean, we've seen that, of course, in NLP. With text generation, you have models like GPT-3 that are really kind of impressive in the way you can give them a few keywords or maybe the prompt, and then they can generate long text, could be multiple paragraphs and so on. And we've been interested in other kind of synthesis kind of work, like maybe more image synthesis or code generation with models like Codex, for example, lets you create code. And of course, I mean, it's really impressive, but at the same time, you've seen the limitations of that. I mean, when you kind of, people kind of joke sometimes when they see the output of GPT-3 because it does sometimes kind of crazy things. And so I think the paradigm, I mean, it's pretty clear that the paradigm these days to do this kind of impressive generation synthesis tasks are mostly one shot these days. And I think people are starting arguing that, well, maybe it's not the right approach. Maybe we should take more kind of course-to-find approach to doing this type of very hard generation task. And for text, would mean maybe, well, rather than writing a full document from kind of just one sentence, which of course is very hard, almost impossible. Well, what about kind of having some kind of interaction between the system and the user, maybe to first create an outline and have different steps also along the way. For image would mean maybe kind of have a kind of rough sketch of what you're trying to generate. And same for code, you might want to have some kind of intermediate representation. So the idea here is really kind of for as AI and NLP moves towards much more challenging tasks in terms of generation, content generation, I think there ought to be more kind of a user envelope. And I mean, to more specifically motivate that from a text or NLP standpoint, I mean, let's look at some kind of GPT-3 output. So this is this output on the screen here is taken from the latest model of GPT-3, so it's the latest Da Vinci model. And in bold is the query giving to the model. Like Jeff Hinton is one of the leading lights of the field of artificial intelligence. And all the rest is generated by GPT-3. And well, at first look, it looks actually quite impressive. So it gets right, but Jeff Hinton got the Turing Award. Well, he got the year wrong, but mentioned the co-recipient Lam Lequin and Joshua Benchio, and then talks about other things. And I think most of that is correct. I mean, except at the end it says, well, deep learning has been around for 100 years. I would say it's more accurate to say 60 years. But yeah, it's pretty good. But well, there are a few hallucinations. And I think, well, it's kind of a good case here. I mean, if you give context about a less famous person, you probably have much more hallucination. That's why kind of grounding is very important, of course. But I would say here, in terms of this task of kind of doing kind of really hard kind of generation task. The more fundamental issue here is that, well, maybe it's not what as a user wanted to have. Like here, it talks about Hinton was giving a talk about deep learning, blah, blah, blah. Few people had the misconception that deep learning is a new idea. So I think, well, that's kind of fine, but it's maybe not what the user had intended. And that goes to the core of the problem. I mean, people think, well, maybe GPT 4 or 5 or etc. will be the solution to the problem, but it doesn't fundamentally address this issue. So I would argue here, I mean, other people, of course, argue here, but I mean, also earlier today in other invited talks, that the GPT X alone might not be the solution. So in that context, I think it's really fundamentally a one-to-end problem. I mean, if you give it a prompt, maybe the user wants to talk about many different things, maybe Hinton's appointment or awards or many other things. So that's really a fundamental issue with sparse input to more detailed output. So now, I guess in terms of motivation really for dialogue research, I would say that you have these really two big areas. One that is, of course, dialogue and interactive system are really big and a lot of work in that space. And that's, of course, very important. And kind of other parts of NLP or AI do other things of other research here on more content generation. And I think historically, kind of maybe the content generation task, like for example, for text generation, were perhaps a bit simpler, like machine translation, where you don't really necessarily need a lot of interactivity. So that was fine to have these two areas to be kind of separate. But I think as we move towards content generation, but much harder, I think there ought to be more at the intersection of these two areas. And I, of course, want to acknowledge there's a lot of very kind of emerging work in that area. So one example is NeurIPS had the Igloo competition last year, which is about some kind of grounded interaction about building structure in Minecraft. Could be like, say, a house. And other work, for example, from Stanford, you have a co-author paper that is kind of on having a data set on collaborative writing. But to me, I think what's really interesting in that space, and that's why I think it's really interesting for dialogue researchers, that space in the middle is a new form of task-oriented dialogue, because here, what is being generated is not the dialogue itself. So we're not talking about a conversational turn generation, but it's still about reaching a goal, let's say, writing a document that has to kind of match certain ideas of the user, and that can be done interactively. So it could be either just interactive or it could be with dialogue. Now, of course, it's whenever it's user in loop, it makes it really hard. And I think that's perhaps one reason people kind of feel a bit uncomfortable about doing work in that direction, because, well, it's not even clear how we can formalize the task, because user in loop, of course, we cannot train. I mean, it's really hard to train system with user in the loop. I mean, it's very costly, and you don't want to expose users with kind of imperfect systems. So I think that kind of gives motivation for a sort of outline of my talk here. I'm going to talk about different aspects of how to get started along this. So perhaps ways to formalize the problem in simpler ways so we can actually get started. And that's work with me and some colleagues, but there is, of course, other work, but I'm going to mention here some of the initial steps we took in that direction. The first one, text editing by command, work by Felix Foltings, that was a NACL last year, basically studies the idea of, well, how can you make kind of an editing process more conversational, like maybe having conversational type commands. You have a document, and then you tell the system, well, maybe add birth here, and then it adds this to that document. The middle here, you have interactive document generation, which is work that is we put on archive soon, which is basically, well, maybe you're not going to talk about the dialogue aspect, but more of the interactive aspect. Let's say you have two agents that can edit the document, the user and the model. And the model tries to draw inferences to kind of get the idea of what the user wants. And the third one is, at the moment, less about interactivity, but I'll just mention this briefly at the end. It's the idea of kind of taking the idea of the first two paper, but more kind of fusing, having notion that fuses multiple documents. So go beyond the notion that we try to match this with a single document, but having multiple documents. Okay, so let me kind of give you a really broad idea of the first paper. And here, because it's invited talk, I'll focus less on the modeling side and really kind of try to motivate the task, because I think this is relatively new, and people, I think, need to be convinced it's an actual task. And I'll mention at the end, like really concrete application of that, where we're starting doing work in that space. So, I mean, here what we want to do is to kind of to model the life cycle of documents. So on the left-hand side, let's have kind of bare bone version of document, could be maybe a start of a bio about Barack Obama, and what the task here is to generate what's on the right. For, of course, I mean, as I said earlier, it's a very difficult problem, one to n, and well, here in that case, maybe GPT-3 can just memorize the target text. But imagine that's not part of a training data. And let's say we're talking about somebody who's actually not famous, and you have to perform that task, and this is obviously very hard. So, well, luckily, we do have supervised data to do that. I mean, if what we did in that work is basically look at Wikipedia data. Wikipedia has kind of all the revisions of all its document, but when people commit revisions to Wikipedia articles, they would also write an explanation of what they did. So they said, for example, here, added birth year, year of birth, and that's kind of, we can interpret this as some kind of command, conversion command. So, I mean, at a certain level, you could say, well, each of these commits, like added birth year or added years in office, is kind of a user talking to their system and say, hey, do that. Well, it would not be phrased exactly, you perhaps that way. Maybe you would, a real user would say kind of maybe in present tense rather than, I mean, more imperative rather than past tense, but that's something we leave for future work. So the idea, I mean, as I said, I was trying to focus more on the task definition. So the formulation of this kind of initial task is to say, well, you do have a document, let's say here, a piece that somebody writes about Barack Obama. And then you're looking at a specific sentence or a block of text, in that case is a sentence. And here you have Barack Obama was 44th president of the United States. And then you have those commands that come from Wikipedia. And well, in this workshop, we're interested in grounding. So here, that command would be really hard if you didn't have some kind of source information to be able to perform this task. So, I mean, again, here, maybe Barack Obama is not the best example because that information might be in a model like GPT-3 or BART, but imagine this would not be a famous person. So you do have a grounding to actually help that. So what we did here in terms of grounding, basically, based on the query and the document, we get search results. Well, to not kind of be loopy here, we of course we exclude Wikipedia as a source because the data we're training on is Wikipedia, and the task is to generate a revised version of that sentence, and that's the setup of this task. And well, I mean, as I said, I'm not going to talk too much about the model. The model itself is actually pretty straightforward. What we did is basically is to have a transform model that takes a combination of the query, the grounding, the current document, and its sentence in the document. The goal is to generate the revised version of that sentence. And yeah, so I mean, it's actually, the results actually quite positive. I think we see that that having all of this together does help. And in terms of accuracy, here we have a kind of ranking task where we show that combining all these things together with grounding and the command and the original document actually helps. But I would show here maybe some example of what you can do here in that context of this kind of relatively simple task formulation. So you give the system a sentence here, something a bit nonsensical. Jeffington is an English player. And with that model, you can issue a simple kind of conversational command like a fixed profession, and then it gets that right. Mostly, I mean, it's correct actually here. Add nationality, Jeffington is an English Canadian. Add birthday, here it got things a bit wrong because perhaps we wanted also the date, but it just says born in 1946. And then add most famous work, and then it does something, writes something quite relevant to that. But that's kind of, that work is more kind of preliminary, and I think the goal for us was really kind of to go beyond single commands, because at that point it's not really kind of interactive. And so what we're looking now at Microsoft Research is to kind of go beyond this kind of single command editing, and also go beyond the limitation that earlier work required supervised edit data, and which is generally not available for different types of documents and genres and different languages. So the current work we're doing, and but we'll put on archive relatively soon, is kind of goes beyond that, and it's really going to the core of interactivity, which is that you the goal again is to generate a target document here, for example, a story about tennis. And what we want to model is kind of the entire life cycle, going from an empty document where maybe the user just input a few keywords, and then both the user and the system kind of edit the document together. And so the idea here is kind of to go beyond what can be done nowadays with, let's say, software like Google Docs or Microsoft Word or any kind of editor, where some of them have features like autocomplete, but we really want to go beyond that. And the kind of thing we're envisioning at the moment, and I'll get more into the details of how we can do this kind of thing, is we want the model to kind of draw inferences of based on what the user does. So let's say on the left, you have a model like maybe, let's say, BART of GPT-3 writing something, but maybe there are kind of factual inaccuracies. Maybe there's some hallucination. And is here maybe the user really intended to say, well, in the original document was, she will face Bianca, etc. And the user, say, for some reason, really wanted Naomi Osaka. So replace Osaka with, and write it in the document, and then you want the model kind of to, akin to a ripple effect, that takes these sometimes minimalistic user input to kind of draw inferences to revise the rest of the document, so that the user doesn't have to fix everything. The user maybe can fix 1 or 2 words, and the rest will kind of by itself, because these models are kind of very rich. They do incorporate rich knowledge in them, but also some version of them are grounding. So you want the model to be able to do this kind of inferences. And I'll show some example that our model currently can do this kind of thing. And I just mentioned along the way that this is related to kind of a really exciting work I find on counterfactual reasoning done at the University of Washington by Yejin Choi and colleagues, and Yanhui Jin. That is kind of a different context. Okay, so our approach in that setting is basically we want to train what we call an edit model that is transformer based, that will at each step generate a document, but then we want an oracle that kind of make those revisions and feed it back to the model. Well, as I mentioned earlier, doing that in I mean, typically you want to do this with real users in the loop, but that's of course not practical because, well, you cannot retrain system with real users in the loop. So I think in a demo sense, you have this oracle to be an actual human, but during training, we do something different where basically whenever we get a version of the document out of the model, well, we have this assumption that the oracle knows, have a kind of have a mental picture of what the target document needs to be. So here we have a gold document D star, and basically we have a machine oracle that kind of look at the differences between what is being generated at the moment and what's the gold. And with the model, I mean, concretely use BERT score here, try to align the two and gives concrete suggestion of what to change. So that's kind of a surrogate to the human oracle, to the user. But actually, we found that works relatively well because it focuses on things, the core pieces in the document that are wrong that will need to be corrected. So, okay, but now that's kind of giving you the idea of our approach. I also mentioned that while we're looking at 2 different kind of transformer, I mean, you can do this with a really regular seq-to-seq transformer. And that's perhaps, I mean, most obvious thing to do, where basically you take some piece of text and you expect the model to kind of to correct those kind of mistakes. And the mistakes, like in that case, like you want to kind of, there's some inconsistency here between Osaka being Canadian, and you want the model to fix that. And we also look at non-autoregressive transformer generation, and that I mentioned that because that tend to work a bit better. But now, well, I think what's interesting here is that what we want to be able to do is kind of to do generation with just raw text. So remember what the first part of the talk was about doing this in a supervised learning setup, but we often don't have that. So what we came up with is an imitation learning setup where basically we just rely on gold documents. So let's say you have a collection of gold document, could be anything, like it doesn't have to be even Wikipedia, it could be some raw text from the web. And then because we don't have supervised data, we don't have supervised edit data, we want to model kind of a life cycle of that in a more kind of latent way. So we formalize with a Markov decision process where we start from an empty document. From the empty document, the user will kind of input a few words, and then you have a generative story where at each document, D1, D2, and D3, basically what you get is a reversion of the document of the model based on your keyword that had been added. And what's in the current document is essentially a representation, of course, of the words of a document, but also a key part here is to memorize what the user entered. So if the user maybe replaced the name of a person with Osaka, you want to remember that the user typed that. So it's kind of, it's almost that you want to protect that information. And yeah, so, and then kind of this imitation learning setup, basically, you have an expert policy that tells you how to take the current document to the goal document. And then that's really the learning setup. So in imitation learning, maybe perhaps some of you are not very familiar with imitation learning, but it's very similar to supervised learning, except that here you have an expert policy that tells you how to go from a current state to a goal state. And we're trying to imitate that. But the way it's different from supervised learning is that those demonstrations, the one you have, for example, on the slide, is not something you have observed. Like, it's not like you can download it from the web. It's constructed dynamically, but otherwise it's pretty similar in terms of imitation learning and supervised learning are very similar. And we use different techniques to do imitation learning, including behavior cloning and Dagger, and Daggers happens to work fairly well. So, I mean, to give you a kind of, we would have more examples in the paper, but to give you a gist of what's happening here with such a setup, you have a user typing Djokovic, Federer, and the transformer kind of does some inferences here, and it writes Federer will now meet Djokovic in the final of the US Open, which actually is pretty good inference because the two players here, they were often high seeded, so they would often meet in the finals. And then the user said, well, I didn't mean US Open, I meant Australian Open. So the user just makes this modification, and then the transformer model kind of makes further inferences where it says, well, it's in January, it infers that Australian Open is in January, which is correct. And then it got also right that it was in 2019, but actually the two of them met in the final. So now, I do have an evaluation slide here, but it's mostly to kind of make the point of how we can evaluate such a system, because you would say, well, if you compare an interactive system with a non-interactive system, of course, it's unfair to the interactive system because maybe it has more input. But to make really kind of a comparison apples to apples, we have a setup where all evaluation systems are given the same budget in terms of input from the user. So so let's say, I mean, in our case, if I recall correctly, the number is 10. So we give each system like 10 opportunities for the user to give words to the system. And what to use here is the most informative words using a IDF scoring of the different words that needs to be part of the target. And we compare two kinds of systems, one-shot systems that where the system gets all these kind of informative words like TF-IDF weighted all upfront, and the interactive system, they get them along the way because maybe some of them not even needed. So let's say one example would be you give the system Barack and Obama. For likely, you can probably guess that Barack is with Obama in would be the two words would be in the document. So some of them is perhaps kind of unnecessary. So the bottom line here is, if you look at the right side of the slide, interactivity actually concretely does help in terms of blue evaluation, and we have other metrics in the paper that shows that this improvement is consistent. So basically, in this setup where every system is given the same amount of input, interactive does help. And now, just checking the time. I'll also mention work done with Ellen Wu on what we call automatic document sketching. And the motivation here is that a lot of work in terms of document creation is quite repetitive. Sometimes maybe people write kind of annual report or this kind of thing, but tend to be the same year after year. And I think people really kind of tend to plagiarize themselves when they write something. So maybe somebody would write a recommendation letter and maybe they would kind of start with a few sentences they might have written before. And I think the goal here is kind of to reduce the overhead of doing that. And I think that could be really kind of interesting longer term in terms of doing this interactively. What we did in that work is not yet interactive. I think it's really about going with the first step. So you have, let's say, you give a system a collection of documents, like maybe annual report from different years, and kind of automatically devise some kind of template that kind of generalizes the different document. And the way we did this is basically with a reinforcement learning. So we have the same challenge here compared to the earlier work. We don't really have good supervised data for that. So so the setup we had is you have a collection of documents, and in that case, the Democratic National Convention, and you have different years here. And then we use a transformer-based mixture of experts, but whose goal is to generate kind of text that is actually unseen in the training data, because we don't have template in the training data, but it tries to generate things with sort of gaps in the middle. It's more like filling the blank kind of text. And then the goodness of that template is judged by its closeness to the held out document from that collection. And we kind of try to see with here word function in this R server, we need a word function, and what we use here is a word array, and to try to kind of optimize the model as to maximize 1 minus word array, or to put differently, to minimize word array. And that works fairly well. And again, I mentioned this was not quite interactive, but we had plans to go beyond that and really make it a more interactive setup. Okay, so I'm slowly reaching the end of this kind of really high-level overview of this different thread, and I really want to kind of mention here is kind of really the big picture, and didn't want to get too much into the details of the model. And I think really the idea here, and I want to emphasize this again, the idea of having something like interactive document generation or content generation is really to get the best of both worlds, and human and machine intelligence. As I mentioned earlier, I think it has really high relevance to dialogue, because to be able to do that, we need some kind of interactivity. And people might say, well, might wonder, what is it? Is it really concretely useful to have interactive document generation? I mean, people might be a bit worried, but it's maybe not really concrete task. But I can give example of where it's really kind of very, I think, would be very useful. And one would be in high stakes application like medical. And it's actually something we're starting to work lately with Microsoft Health Future. The idea here is that there's some high stakes situation like medical. So you might have heard that, well, I mean, physicians, some type of physician are really kind of overburdened by kind of the need to meet with patients during the day and write reports like documents about these meetings with patients in the evening. So typically a physician would have assistants to do this kind of work for some kind of less physician that have less medical support. Medical stuff is of course kind of sometimes hard to come by, especially during this COVID era, where they would have physician would oftentimes spend most of the evening actually just kind of writing down the medical patient reports based on meetings you had during the day. So, but I think that's a situation where maybe some kind of AI could help them kind of in this task, really reducing the burden of creating documents that would need to be written anyway. And I think the key part here is to make it to have user envelope, humans in the loop, and especially medical doctors in the loop, is that because they're involved, they're in the loop, we can kind of there to fix any inaccuracy, so that if a generation goes wrong, they can fix that and hope to kind of has the whole process kind of reduce the burden of creating those documents. And I would like to mention before the end of my talks. This is kind of unrelated, and that slide is actually the one that is really more directed on dialogue. So you might have heard of DialDoc, which is a model, open source model that Microsoft has released 3 years ago now, that has been quite extensively used in the research community to kind of build the dialogue model. And we're happy to say that we'll release soon a new version of that model. It's called GODL, Grounded Open Dialogue Language Model. And this time, this model, so DialDoc was not grounded. This new model is grounded. So basically, you can condition the response on some piece of text you're providing externally. And the key technical contribution of that work is grounded pre-training. And it's the data set is much larger. It now incorporates MS Marco. And we try to have different phases of pre-training, one that is also grounded pre-training. And I think it makes it more very kind of relevant in this context of having generative conversation with grounding. And we fine-tune on different benchmarks, including task-oriented dialogue, conversational QA, and grounded open domain. And we have both intrinsic evaluation. We ask about the humanness of a response, and also extrinsic evaluation, asking about the usefulness of a response. And we'll release at least 3 models, base, large, and extra large. And the extra large one is based on GPT-J, an alternative to GPT-3, because we could not release a fine-tuned version of GPT-3, so we're releasing one that is based on GPT-J. And the expected release is, well, in a couple of weeks. Yeah, so I think that's basically it with my talk. And like, again, thanks a lot for Felix Foltings and Ellen Wu and other researchers and visitors at Microsoft.